Can you hear me?
Yeah. Hi, everybody. Welcome to the third webinar in the webinar series that Spadeworks is organizing on Azure. Today, in this webinar, we want to talk on a storage-based file management system on Azure. So, Azure Storage offers uh, blobs as the storage mechanism. So, we would like to share our thought process behind developing a solution uh, of a file management system. So today we will be covering various aspects. Uh, the file management system, a business need. We will touch upon later what is the solution, and we will also touch upon a quick demo uh, on this file management system. And we also will take question and answers. You can submit your questions on the webinar window, and we will take them up at the end of the session. And before concluding the webinar, we also will have a brief introduction to Spadeworks. So we will start with a brief introduction to me and my colleague. So I'm Srini Pule. I'm leading the Azure and mobile practices at Spadeworks. I am having around 17 plus years of experience in the IT industry in various capacities, starting from a developer to other roles, from delivery to sales and pre-sales, etc. So the current focus for me is on cloud and mainly on Azure technology, as well as the mobile enablement of various solutions. I have my colleague Saif, who is an architect. Saif, can you please introduce yourself?
Thanks, Srini. Hello, everyone. My name is Saif Mandlik. I'm a solution architect in Spadeworks team and more into Azure and cloud-based solutions. I have a total of around 14 years of experience in IT industry, mostly or all into Microsoft technologies in development as well as in various other roles of consultancy and so on and so forth. And currently I'm very much into designing, solution architecting, uh, helping our clients over their requirements and making best use of Azure and Azure related services for them. Yeah, over to you, Srini.
Thank you, Saif. So coming to today's topic on the file management system, uh, what we are noticing is the with the products like Dropbox and Box.net, uh, more and more people are looking for a cloud-based, full-featured file management system like Windows Explorer on the web, where users will be able to manage various files in the cloud from anywhere in the world using internet. Not only that, the key part is the browser is being expected to function in place of the regular Windows Explorer. Of course, there are standard Windows-based native client applications. However, for a faster and better access, people are anticipating to use browser for operating on this type of a file system. Uh, so based on our experiences while developing solutions on Azure, we came across uh, one of such needs where the customers are looking for a full-fledged file management system on cloud. Azure has some of the key functionalities like storage area, which is very less expensive, and we conceptualized a solution leveraging the less expensive storage offered by Azure as part of this such a requirement. I will hand over to Saif again to walk us through the requirements as well as the solution followed up with a demo. And at the end of the session, we will be happy to take up any kind of a questions. You can put your questions on the webinar window. Uh, Saif, over to you.
Thank you, Srini. Okay, Srini, is the screen visible?
It's getting loaded. Yes, it's visible.
All right. Yeah, so to start with, what are the requirements of such a system? One of our clients came back to us saying that they want to enable collaboration between the users so that users can share files amongst themselves, and they don't want to have multiple versions of those files floating around over emails and stuff like that. Also, they want to give users a private area, a private space in which the users can save their particular files, their private working copies, create folders and subfolders inside it, organize files inside it. All these seems to be pretty simple and straightforward requirement. That's how we all do our day-to-day work using a Windows Explorer and file system. But here the requirement was different. Here what they wanted is the files, the private files as well as the shared files, whatever files. The files should be stored somewhere on the internet so that it can be easily accessible. It can be easily accessed from internet, right? So necessarily you don't need to have your office laptop, or you don't need to be logged onto your intranet to access a file or to share a file with other users. Instead, if you have a browser, that should be good enough. So the whole idea is to have something like a Windows Explorer, right? But the UI should be Windows Explorer, but the file should actually not be stored on a local file system or a network, but instead it should be stored somewhere on the internet. That was the main requirement. The second being, of course, since your important files, your sensitive files are going to be there on net, the system has to be secured, and the system has to be extensible and reusable in future. Right now, they are thinking of file sharing and file management. Later, they would like to enable versioning over it and stuff like that. So for that, the system design should be good enough. This was the basic core requirement, functional requirements, which made us think, the development team, about the technical requirements. All right. So the client is not insisting on any storage, right? What they are saying is, okay, it has to be an internet-based storage or a storage which can be accessible from anywhere. Obviously, the moment you say accessible from anywhere, that storage cannot be your intranet or your local machine, but it has to be somewhere on the internet. We considered going for maybe a SkyDrive or a Dropbox, but then the client insisted that if we use a SkyDrive or a Dropbox kind of a storage, then they don't have that much control over it. Rather, they would be more comfortable if they have more control over things, though they might be on the internet. So that was one request that they had it on their mind. Then the option came up is Azure, that okay, if we take up an Azure subscription which you own, right, and you have an SLA with Microsoft, so the VMs are yours or the Azure blocks are yours, would the client be comfortable? And they came back to us saying that yes, we would be fine if you save it on and Azure cloud-based platform. Uh, Being well aware of Microsoft and its security and their background, they were comfortable with the SLAs as well. Now the question comes that the storage platform is finalized, which would be Windows Azure Cloud. However, in Azure Cloud, there can be multiple places where you can save the file. Suppose the UI of exposing your folders and subfolders uh, would be through a web role, and this web role obviously is going to be deployed on a VM. Then the files can be stored on the local drive of the VM itself. However, this would not be persistent because we all know that Azure VMs are susceptible to uh, recycles. And the moment the recycle happens, whatever you stored in your local storage is lost because your whole VM is recreated. So anything that you store at runtime is lost. So that is something which was out of the question. Then next, obviously, table storage. We cannot go ahead with table storage because the files can be any files, right? They are not essentially an object, a structured object or something. So then the obvious choice would be was blob storage. Blob storage gives us a good, reliable, durable, cheap, fast medium of storage of files. So it was, and all the architects were quite comfortable going ahead with blob storage and actually saving the contents of the file in the blob storage. The requirement was also of not just storing the file, but also uh, you know, uh, uh, keeping the files in different folders and subfolders. As we all know that the blob storage has just the concept of a container. Inside container, you cannot actually have physical folders or subfolders. You can only simulate that kind of a effect by having your forward slashes or backward slashes in your blob name, but then they are not actually your physical folders or subfolders. So we decided to have the whole system data to be an RDBMS or a DBMS based data, where we will save all the data of the system in terms of the users and the permissions that they have, the folders that they own, the subfolders and the subfolders inside it, and the files which belong into that subfolders. At least the metadata of the file, the name, and all those parameters would be DBMS based. And the actual file content, the binary of the file content, would be stored in an Azure container. And its reference would be into the DBMS, so that whenever you do want to download a file, you can pick up the reference of the blob from the DBMS, go back to the container and download it. That being said, security also was an important aspect of it, and being a tricky part of it, we decided to go with ACS, right? Because ACS takes provide us with federated security option. It abstracts the application from a lot of security hazards. Besides, since the files were supposed to be accessible over the net and maybe by outside users, ACS by default gives us some basic identity providers in terms of Google or Yahoo or Windows Live. So we went ahead with that. Now, the biggest constraint in implementing this solution was the time. Our delivery time was actually 3 weeks. From the day when the business team came back to us saying that this is what we want and this is what we want in 3 weeks. And we were like, just wow, how do we achieve this? So we went ahead with doing a bit of analysis and finding out if there were any open source projects available which can be used to some extent to reduce our development and design time to our good use. Uh, there were two open source projects which combined together met a lot of our functionalities. One is called as Blobshare, which is a web-based file sharing or blob sharing system developed by Microsoft Customer Advisory Team, and the code is available on CodePlex. Right. So what Blobshare provided us is the capability of creating users, putting them in roles, then creating folders and subfolders. All this data will be in a DBMS or an RDBMS, say SQL Server, or even for that matter SQL Azure. What Blobshare also gave us is the capability that it was actually storing the contents of the files uh, in Azure Blob. Wow. Last but not the least, Blobshare already had integrated with ACS and it was using uh, Google and Yahoo as identity providers. Wow. So almost most of our core requirements were fulfilled. However, there were few functional limitations of Blobshare which we worked around with as per our requirement. I'll deal with that as we go on to the next slide. The other open source project that caught our notice and seemed to be a good fit for this solution is lfinder.net. So lfinder is actually an open source project which has two components to it. A server-side component which exposes certain REST APIs in JSON format for a file system, giving the information of folders, subfolders, and files inside it. It also has a UI component in terms of a jQuery plugin, which makes appropriate HAX calls to these well-defined REST APIs. It reads and understands the JSON response and renders the response into a Windows Explorer kind of a user interface. So using this, met our purpose of having a user interface which the user is familiar with. So we decided to use the two, do changes to it wherever we want, and meet our requirements. So next slide we'll talk about what all did the two projects concern. Blobshare, which is on the lowest part of the slide. What all features did it inherently have is you can create users and roles. Users being users of say Yahoo or Google identity providers where ACS was already integrated with. Then it gave the capability of creating files and folders, and then files inside folders, which they inherently called blobs and blob sets. Blobs for files and blob sets for folders. The capability that it had was that the only admin can create folders, add files to it, and then invite users, a Yahoo user or a Google user, to whom the admin would give permissions, so that those users can come to Blobshare and read the files that are shared with that folders. And the files were stored in Azure Blob. So this met our 30-35% of the requirement, but few things that were not met. What we wanted is not just the admin but the user, give the capability to the user to add files, folders, subfolders into the Blobshare system. So that is one capability that we added. And then since we were going to have multiple users and then maybe shared folders, personal folders and stuff, we need to have a very strong, solid permission mechanism, which we extended the existing permission mechanism of Blobshare, implementing explicit permissions as well as inherited permissions. So this covered our backend stuff, the data stuff. The services of the blob shell would return the data required for a user. Uh, the data in terms of the folders, the subfolders, and the files inside. Then the other project that we used is lfinder.net, which actually provided us, the APIs for exposing a file system, and they are the REST-based APIs in JSON format. What we did is we added, we followed the same interface of the APIs. However, what comes inherently with lfinder.net was file system based API through file system connector that they had created. We wrote a blob share connector which would expose the data of blob share in JSON format through the well-known REST APIs of lfinder. So this is how the whole execution sequence goes. The browser will actually have loaded the lfinder plugin, and the lfinder plugin has the capability of making AJAX call to the predefined REST APIs. One of the APIs, so BS connector, which is blob share connector, is the actual endpoint where the APIs we have exposed. And the way it works is in the HTTP request, you need to specify the command, the different commands being open command, tree command, and so on and so forth. And then the blob share connector controller, which is actually a web app and MVC4 based web app. This controller gets the HTTP request. In terms of processing the HTTP request, it forwards the request to lfinder blob share driver, which is actually responsible for making appropriate calls to blob share service, get the data from the blob share service in .NET format, convert it into the JSON format, and return it back to the browser's jQuery plugin, where the jQuery plugin would then eventually render. The REST APIs that are blob share connector supported is obviously, again, all the REST APIs listed in lfinder. We have to support it, because if we don't support it, the lfinder plugin will cease to work, right? Because that plugin works with this set of APIs, so we had to support this set of APIs, and once these set of APIs were properly implemented, lfinder plugin works just seamlessly. The APIs that we supported, or the methods that we supported, were opening a directory, file, tree, parent, list of files in a folder, make directory, delete directory, rename directory, and upload a file. Okay, having said that, time for a demo. This is how, what I was saying is, this is the lfinder plugin, whose UI looks quite similar to our Windows Explorer. What this plugin is actually doing is, it will fetch the data from the blob share connector controller, which in turn will fetch the data from the blob share services. So if I switch to my Visual Studio, right? First, let me show how it works. Is the moment you log into our file management system, it is swxfms.cloudapp.net. It will, if it's not an authenticated user, it will first take you to the sign-in page. The system is being integrated with ACS, and 2 identity providers are configured. The ACS to which it is being integrated with is FMX, SWX, FMS ACS. And if you see here, in this ACS, and in this ACS, what we have configured is the two providers are configured. Right, Google, Yahoo, and but the live provider we have actually disabled it. The reason being, in the system we needed a user's username and email address as well. Google and Yahoo do provide us with that, however Live does not. So for this demo we have disabled Live for now. This is what comes up over here, Google or Yahoo. Now when I log in or when I select Google, what happens is through the ACS, the request goes to ACS. The ACS will redirect me. I'm already logged in, that's why the Google page did not come up. I'll try logging in again. What happens is the ACS will redirect you to the Google login page, and that's where you will enter your credentials. Google will log you in, and then Google will redirect you back to the ACS, and the ACS will redirect me back to I have to log out. Okay. So I need to clear the cookies. It has saved me in. Uh, and let's see. Clear the cookies. Just one second. Bear with me. Oops. Sorry about that. Maybe we can try another browser. Maybe we can try Firefox. This is taking time. SWX. Google. So my app is redirecting me to ACS. ACS is redirecting me to here. Google login. Now, once I enter the correct sign in and password, Google will redirect me back to ACS. ACS will redirect me then back to my application, and boom, I'm there. So this username I'm getting as one of the claims of the ACS. Now, if you could see this here, what we have is an interface very similar to Windows Explorer, right, where you have folders and subfolders inside it, right, and all this data is actually saved in uh, an SQL Azure database. But the files are actually physically present in Azure Blob, which is one of the blobs, Azure Blob storages that we have used, and FMS container is the container that I have configured. So if you could see here, currently I have 1, 2, 3, 4, 5 blobs inside FMS container just to prove that the system works. Now, if I add a file to it, if I upload a file to it, the file has been uploaded here. This, okay, just to show you. Uh, okay, this is the preview. You can also download the file. It's the same desert file, and this file physically resides into this FMS container. As you'll know, earlier we had 5. Now when I added one more file inside it, and if we go here, when I refresh it, I have now 1, 2, 3, 4, 5, 6, and I think it's this one which I just uploaded it right now. Difficult to move. Which file must have come in, but then one of the files that I have uploaded has come here. You can delete a file from here, right? I hit delete. We want to delete. Yes. File is gone from the database. Plus, if you see it in this Azure Blob, if I refresh it, the file has been deleted. We are back to files. From the solution standpoint, this is what the solution looks like. We have a web role. So the solution consists of 2 main elements. One is the blob share related projects, and other is Elfinder related projects. Srini, can you hear me clearly? Srinivas?
Yes, yes, sir.
Okay, sorry, I just got a pop-up, so I thought maybe there's some network problems or something. Yeah, I'll continue. Blob share related projects are something core, blob share core, which exposes all the services related to exposing the blobs or the files, its folders, its permissions and stuff. And then you have blobshare.data, which actually has the entity framework data model. The security is where the SES has been integrated. And blobshare web is the UI where you can actually add users, rules, and then create folders and subfolders. In this web, what we have done is we have added one more controller, which is a blobshare controller, which is actually a blobshare connector of Elfinder. So the reference here is to the Elfinder plugin or the Elfinder project. And in the Elfinder project, if I go down here, there were two components. We did not use lfinder.net.web because we had Blobshare's web that we wanted to use. We used lfinder.net library, which came up with file system driver. What we did is, since you all can see here, we added one more driver, which is a Blobshare driver. This driver actually exposes all the same interface, which is iDriver interface, same as is the same interface that the file system driver implements. And but for implementation, this Blobshare driver, instead of retrieving data of information of folders and files from a system drive, it gets the data from Blobshare. So if you see here, I have references to the different Blobshare DLLs here. This is what it retrieves the data, and then this driver is being used in Blobshare web, Blobshare controller over here. The driver is being used, and the data, the incoming requests are forwarded to the driver. So if you see here, the instance of the driver is created, and all the incoming request is forwarded to the driver. And the connector process method is where the request is forwarded to. Okay, so that's pretty much it from my side. Back to you, Srinivas. Any questions?
Hi everybody. If you have any questions, we are open for questions. You can put the questions in the question panel of the
Do you
webinar.
want me to?
So Saif, looks like there are no questions. I will just quickly go over SpadeWorks into SpadeWorks B. Okay.
Do you want me to give you back the control? Okay. Thank you.
So thanks everybody. Thanks for attending this webinar. Just want to quickly go through SpadeWorks brief. SpadeWorks is a 6-year-old company headquartered in Pune, having offices in USA, Singapore, Australia. SpadeWorks is into the custom software development as well as product and solution development. And of course is into mobile and cloud offerings as well. Since beginning, SpadeWorks is focusing more on Microsoft technologies, whether it is SharePoint, Azure, or Windows Phone. However, we also focus on mobile application development on Android and iOS. The key differentiator SpadeWorks offers to the customers is its user-centered software methodology. SpadeWorks has a trademark UCSC methodology. It is user-centered software engineering, which is more focused on the end consumer of the application rather than engineering artifacts. So the complete solution conceptualization, development, and delivery is focused based on the end consumer of the application. This helps in delivering innovative and intuitive applications to the customers. Yeah, since beginning, SpadeWorks successfully delivered more than 150 projects to customers spread across the world. In the 6-year span, SpadeWorks achieved a lot of accolades from the industry, IT industry. Silicon India, which is one of the top IT recognition industry bodies, identified Spadeworks as the top 10, one of the top 10 most promising companies. And NASSCOM is the IT industry body in India. It recognized Spadeworks as the top 50 emerging companies. Along with it, Spadeworks also won the IT award from Maharashtra state government in year 2010. With this, I just want to conclude this webinar. Thanks again. Thanks for joining this webinar. We will be having another webinar on October 2nd. Would like to catch you up there in our next webinar on October 2nd. Thanks a lot. Thanks, Saif.
Thank you, Srini. Thank you, Srini.